Standard deviation. Consider these two sets of data, and we're asked to calculate some statistics about them. Now, because they're perfectly symmetric, it should be easy to see that the mean is 5 for each of them. And of course, the median would be the same because they are perfectly symmetric. The mode for the first one is 4 and 6. And for the second one is 2 and 8. The range of both of them is 6. The interquartile range, however, if we look at the median being here, there's 6 pieces of data either side. So the upper quartile here would fit in the gap, and that would fit in that gap. So 3.5 and 6.5. So the interquartile range for this set is 3. Here, it would fit in this gap and this gap. So the interquartile range is 5. Now, it should be clear looking at the two data sets that this set is more spread out than this one. The indication of that in terms of our statistics is the difference in the interquartile range. So, many of the statistics are the same. The mode is of little use as each dataset has two modes. Perhaps the interquartile range is the most helpful. It tells us that set A has its middle 50% closer together than set B. A new statistic called standard deviation will also be different for these data sets. It measures the average deviation or distance of the scores from the mean. It is used to compare the spread of data sets. So like range and interquartile range, it's a measure of spread. Like the mean, it uses all of the pieces of data. I'm going to give a very brief explanation. Let's suppose we had 4 pieces of data. The mean would be in the middle here somewhere. Let's call these x1, x2, x3, x4, and in the usual way we'll call the mean x bar. This distance would be x1 minus x bar. This distance here would be x2 minus x bar. This distance here is x3 minus x bar. And this distance here is x4 minus x bar. If we want to work out the average distance, we could add up those values and divide by 4. Our problem is that the mean is exactly in the middle. And this would be negative, this would be negative, this will be positive, and this will be positive. These ones will be negative because x1 is less than x bar, and these will be positive because x4 is more than x bar. But because the mean is exactly in the middle, when we add them up, it comes to 0. So what we do instead is we square them. And we do x1 minus x bar squared, now it's positive, plus x2 minus x bar squared, plus x3 minus x bar squared, and x4 minus x bar squared, and now they're positive, and we divide by 4. You don't actually need to know this, you just need to know that the standard deviation is a measure of dispersion of data that uses all of the data, just like the mean does. A small standard deviation tells you that the scores are closer to the mean than a larger standard deviation. Now, if you're going to do this, you're going to do it using your calculator. We're going to use the stats application, and we're going to enter scores and frequencies. And remember, a smaller deviation shows the scores are more consistent. So we're going to use dataset A and dataset B, and we're going to work out the standard deviation. And we would expect that set A is going to be smaller because we can see that the data is less spread out. So I'm just going to grab my class pad. Let's just resize and clear what we had. And let's enter dataset A. So dataset A has 2 3s, and 3 4s. It has 3 6s, 2 7s, and an 8. And I'm going to go to calc, one variable statistics. My data is in list 1, and the standard deviation is the one sigma x here. So 1.826 to 3 decimal places. Now let's do the same thing for the other data set. So we have 3 2s, 2 3s, and a 4. We have a 6, 2 7s, and 3 8s. Now, calc, one variable, all of that's okay. My sigma here is 2.449. And so, by this measure, this one does have a greater dispersion than set A, just as we can see visually.